All right. Hello and welcome to the HydroGraph Fireside Chat. My name is Robert Blum, managing partner here at Lytham Partners, and today I have the pleasure of moderating a Q&A discussion with Kirsten Brewer, the company's Chief Executive Officer. Kirsten, welcome.
And thank you so much for having me.
Fantastic. Let's start sort of a little bit high level. Walk me through the HydroGraph journey from its inception to becoming a publicly traded company, and maybe add a little bit of a background on yourself and how you came to the company.
Sure. So this was really a result of an experiment that happened at Kansas State University in 2014. Dr. Chris Sorensen had discovered this production process by looking at aerosol gels, which was really a serendipitous discovery. He was detonating different hydrocarbons and had realized that he had made the world's highest purity graphene. And so that patent was granted in 2016. HydroGraph was formed in 2017 and acquired the worldwide exclusive marketing rights to that patent. I joined in the beginning of 2020. I was effectively the first employee, so I was just working for Sweat Equity. I had a lucky introduction to the co-founders. I was working for different tech startups in Vancouver at that time. And I was really motivated not only by the potential that graphene can have across various industries, but specifically this production process made a lot of sense to me, not only in the high purity product that it could yield, but really just the scalability and, of course, the low environmental footprint. So I have a master's in material science and engineering. I was only recently appointed CEO roughly 1 year ago. Share price is up considerably, more than 200%. It was very satisfying, I think, to have wanted to make some changes and then to have a very positive market reaction to those changes.
Fantastic. How do you sort of communicate the value of graphene to let's say both customers and investors who may not be familiar with its potential? And what role do you see HydroGraph playing in sort of this broader shift towards sustainable materials, nanotechnology?
Mhm. I think to take a step back, for those that don't know much about graphene, graphene is really the strongest and most conductive material that's ever been discovered. You could characterize the ages of man by the materials that we've used, whether we're talking about the Bronze Age all the way to the age of silicon. I really believe graphene is going to have more impact actually than silicon, because when we're looking at silicon, we're looking at conductivity benefits mostly, and with graphene we have, also the mechanical benefits. And importantly, with nanomaterials, and this is kind of an odd concept to wrap your head around, but it's really two-dimensional. So you have to add something two-dimensional to its 3D matrix. And really, what I mean with that is that you can kind of layer on these benefits. The future is going to be made of all sorts of different nanomaterials. So I think that we're really entering an age of nanotechnology. And I think graphene is going to be the front runner there. And because it's made just of pure carbon atoms, just one sheet of carbon atoms, graphite is effectively billions and billions of layers of graphene. So you want to get down to that one atomic scale. And of course, we are a synthetic producer, so we don't use graphite. We are an explosion synthesis, but our natural world is made mostly of carbon. So graphene is very versatile. Almost anything you can think of can be positively improved with graphene, whether it's internally for drug delivery systems, biosensors, concrete, carbon fiber, batteries, you name it. And so it's very exciting to have this potentially unlimited reach, and it's non-competitive. We work well with other materials. We're more improving other materials, even other graphenes. Graphenes have a huge synergy, and even other carbon compounds have a synergy. So it's a non-competitive technology, and though it's disruptive, it's kind of non-disruptive in a way.
So let's sort of talk about the process, right? HydroGraph's process, I think, is sort of its uniqueness here, right? Explain how it works, why it's sort of this game changer for the graphene production, and what really sets HydroGraph apart from other players in sort of this broader advanced materials and maybe specific graphene production space.
So I also believe hydrograph will be a catalyst for the overall industry. We are completely differentiated. Again, everything is patented. And it's quite simple in theory. Really, what we do is we pump in hydrocarbon gases with oxygen into a steel chamber. We have electrodes at the top and bottom of each chamber. Those electrodes fire in synchrony. And so our favorite hydrocarbon gas is acetylene. You would know it as a welding gas. It's very volatile. So you can imagine it's bringing a lot of energy with it into the reaction. So we don't need a lot of energy because it's effectively a bomb. We pump in these gases, we ignite the electrodes, the molecules are destabilized, the temperature shoots up to 2500 degrees Kelvin, and effectively all of the carbon that was in the acetylene gets crystallized into a powder. and then the oxygen and hydrogen has to go somewhere, so that is exhausted as syngas. Syngas is not a greenhouse gas, it's a commodity gas. So when you look at the whole system, we use almost no energy and there's no waste because that's a commodity gas. We'll have an offtake agreement for it at scale. So it's a really beautifully simple, at least in theory, process. Of course, managing an explosion of that size is our core competency. But we are able, we believe, because of the purity of our feedstock, and of course, not reliant on graphene or graphite, the purity of our feedstock in combination with the temperature that we achieve is really what we think is kind of the secret sauce behind graphene or HydroGraph's technology for the production of graphene.
So, and maybe you just touched on it there a little bit, but are there any sort of breakthroughs that are going to be needed, or sort of everything set to go from a production process, or anything that you're sort of focused on going forward here?
For us, we feel this is very much de-risked. We've been using these machines for a number of years. We have our commercial unit now. This is roughly 2 meters by 2 meters. It has four of these chambers, these carbon steel chambers. The production output of that one unit is 10 metric tons annually. We are now, of course, replicating those units, but more importantly, we believe that we have secured pipeline access, and we will be announcing the greenfield build of a large production facility within the US.
All right, fantastic. Yeah, let's talk about sort of market applications here. What do you believe are maybe the most promising or the most appropriate applications for your graphene? And how do you sort of look to prioritize which applications to focus on, given sort of this relative versatility across many different industries?
Right. So as a small company, we really want to focus, and my primary focus, I guess there's multiple pieces here. My primary focus is generating revenue for shareholders as soon as possible. Once we have revenue, we can really look at a lot of these more high-tech applications and applications that might take more research. But right now, we are heavily focused on composites and coatings. And the reason for that is it's quick and relatively easy to bring a product to market. And we solve huge customer needs. For example, we can lightweight these plastic shipments for companies. So we have an immediate benefit to the customer because they're generating basically a cost savings. And because the amount of graphene, often less than 1%, is so small, they can then decrease the amount of plastic they're using, just to use plastic as an example. If we're making something 20% stronger, you can use 20% less plastic. So again, it's cost break even. We're solving huge problems for these customers. Generally, these sales cycles or development cycles are about 18 months. So it is a bit of upfront work to really get in, but with materials, it's very sticky. So once you're spec'd in, you're really probably going to be there for a while. And I think big picture, we see a lot of interest from defense contractors. I think aerospace is going to be large for us, and automotive as well.
That sort of dovetails when you sort of think about what are these next steps, whether defense, aerospace, others. When you look at the commercialization approach here, does this become sort of major supply contracts, or how does sort of that help people understand how you get from sort of A to B in that?
Sure. So I think it's important to point out really the catalyst for a lot of these commercial developments, and that is in an innovation hub that we're affiliated with called the GEEC, and that's the Graphene Engineering Innovation Center. It's located, of course, in Manchester within the UK, and that is where graphene was discovered in 2004 at the University of Manchester. So there's really erupted a very strong ecosystem with a lot of the materials expertise. They have all the industrial prototyping machines, all the characterization devices. So really, this group has everything that a company like us needs to bring a product to market. And importantly, the GEEC has their own staff that's separate from HydroGraph that has direct firsthand experience working with the commercially available graphenes. And because we are so high performing and they're under mandate to use the best performing graphene for every customer project that they have, we've been selected for a number of large projects, and we see that only accelerating. So we're in a very privileged position just because of really the technology that we have in hand, that a lot of this interest is really coming towards us. And so we have, I would say, a relatively small business development team that we're currently working on upscaling. But again, a lot of this interest has really just grown through word of mouth. We're having more and more blue chip companies just reach out via our web form. And this is a very exciting moment. And I'll also reinforce, we're only engaged in selling graphene. We will not be selling or licensing the units because, of course, that is really what we see as the value of the company.
So just coming back on sort of this commercially, if an investor, what would be sort of the key items that investors should be thinking about? Would it be a supply agreement of some sort? Would it be that your product is being introduced into another product, right? What sort of becomes I don't know, the key sort of an application or the key event or key press release of sorts that folks should sort of be thinking about as it relates to your point, generating revenues?
So to kind of dive into that 18-month development cycle, it starts with some laboratory testing just to have the data set. With any new material, you need a robust data set to convince the customer why they should be taking you seriously. So that's really the initial steps, which we have done, since going back more than a year. Now that we have those data sets, customers start these projects with us. So then we'll start a pilot scale up. It will then move to an industrial scale up where we might be producing hundreds of kilos of the end material. And once that's complete, we generally move to a long-term supply agreement. So we might be shipping out tonnage amounts of powder, of graphene powder. We might be shipping out dispersions, and we try as best we can to really have a drop-in solution for customers. So it's just easier for them to integrate. And because a lot of these projects were initiated in the beginning of 2024, many of them are going to be wrapping up from summer through fall. And so of the 60 customers that we're speaking with, I would say between 5 and 7 of them are looking for an excess of 1,000 metric tons of annual consumption of graphene. The average customer is likely looking for tens of tons or hundreds of tons. And so we do expect to have a number of larger purchase orders coming through this year. We will be announcing, as I mentioned, the breaking ground for our new large scale facility, which again, I think is going to be a great signal to customers worldwide that we are going to at least theoretically have unlimited production capacity. The only bottleneck would, of course, be the speed in which we can produce our reactors. And by the end of the year, we should be signing some major customer contracts.
All right. So you said 60 customers that you're speaking to, a number that would be sort of at this higher metric ton.
Mhm.
Do you and you talked about aerospace defense. Is that primarily where these applications are right now, or are they sort of expanding into some adjacent industries? Have you disclosed any of these sort of specifics here?
We have disclosed some pieces of that. We are working with large automotive companies. We are also very focused on these technical fibers or these heavily engineered fibers, and that might be a nylon PA6 or a PEEK. And these fibers have applications. So it could be a defense contractor that's purchasing or a chemical company. These can be used for textiles, for ballistic protection, for aerospace components. Because we're really making basic materials, these can be used in a wide range of end industries. But again, we are really focused on generating data for near-term revenue. But if we have a partner that is looking at a new area, it might be biosensors or concrete, of course, we're going to engage. That's just not where we're funding research. And overwhelmingly, customers are paying for almost all of the research that we're doing now.
That was my next question. So again, I hate to call it contract manufacturing, but you sort of have that research component of it. They're reimbursing you for it, and then the supply contract comes following data.
Exactly.
All right, great. Sort of looking at this from a geographic standpoint, you mentioned obviously the sort of the discovery in Manchester there. You're a US based sort of a company here. Talk through sort of geographically, is this sort of something that becomes, we'll call it critical material? Is it something, we've obviously seen a lot of stuff with the critical minerals all around the world. How does that sort of layer into national security concerns or some of the other things that might be at play in today's market here?
Massive, massive benefits. So we're very involved with a lot of these government programs. We've been working with the US military for now over a year. I think that more and more graphene is going to get recognition as a critical material, critical mineral. And again, because graphene can positively improve various materials or metals, you really are less reliant on some of these. So if you can improve copper, you don't need as much copper, of course, to get the same benefit. And I will also point out that Dr. Chris Sorensen, who discovered our production process in Kansas State, he is a Vietnam vet. All of the components in our reactors are produced in America, and we are going to be focused on American manufacturing as well.
All right, fantastic. Sort of looking ahead here over the next number of quarters and even into 2026 here, you talked about scaling or sort of moving a number of these customers through that sort of, we'll call it development pipeline, getting data, getting prepared for hopefully supply contracts. But what are sort of those key milestones and maybe the metrics and achievements that we should be looking for to gauge success over the next couple of quarters and years?
Right. So we have some very large potential opportunities that we've been working on for the past year. A number of them are about to move into the industrial scale up, which is likely between 3 and I would say 6 months. It really depends on the application. So we would be looking at some much larger purchase orders coming in the next few months. And as I mentioned, that would then convert into a supply agreement. But our sales pipeline is growing, day by day, and more we're working with different organizations. We've recently announced a partnership with NEI Corporation, and that is for a dispersion. We have two different dispersions, so it's effectively a drop-in solution for customers to positively improve the performance of their energy storage devices, both for the cathode and for the anode.
All right, fantastic. As we sort of wrap things up here, final takeaways investors should have as they sort of look at this opportunity going forward here.
Right. So, I mean, I think we have a very, very strong economic profile. It's a low capex process. We're very scalable. And as I mentioned, the pipeline access, I think, is going to be absolutely critical for the company. This is really our inflection point. I think it's this year that we prove all the things that we've been saying. I think that we've performed quite well for a pre-revenue company, and it's really time to convert these into long-term supply agreements. And I think, we're going to be a very, very different company by next year. My goal is to list or uplist on NASDAQ by the end of 2020, by the end of 2025, if not the beginning of 26.
All right, fantastic. Well, we'll be watching. To everyone, the investors that are watching this presentation, if there's anything I can do to help coordinate a meeting with HydroGraph, please let me know. You can shoot me an email. That's Blum, BLUM, at lythampartners.com. Kirsten, thank you again so much for your time today. Greatly appreciate it.
Thank you as well.
Fantastic. All right, everyone. We have additional presentations and fireside chats coming up next, so please stick around. Again, thank you, everyone. Have a great rest of your day.